from Kitty Hawk to Cape Kennedy. NASA, the National Aeronautics and Space Administration, presents Aeronautics and Space Report.
Space Highlights, 1965, an eventful year in space. These pictures, telecast live from the moon, were recorded by the Ranger 9 spacecraft just before it slammed into the lunar surface. This was the final mission in the Ranger series, a series which gave us a close-up look at the moon and clues to its character. Another picture-taking highlight, Mariner 4's voyage to Mars, a 325-million-mile journey that returned the first pictures and data ever gathered close to the mysterious red planet. There were two TIROS weather satellites placed in orbit, TIROS-9 and TIROS-10. Between them, they spotted 5 hurricanes and 14 typhoons. Their television eyes transmitted thousands of photographs of the entire Earth to aid weather forecasters. Early Bird 1, the world's first commercial communications satellite, was launched by NASA for the Communications Satellite Corporation. Early Bird provides telephone, telegraph, high-speed data, and television between Europe and the United States. One of the 14 scientific satellites launched was an orbiting solar observatory, OSO-2. OSO's instruments provided information on the seething hot gases surrounding the sun and how its tremendous energy controls events on Earth and other planets. More than 400 sounding rockets were launched during 1965. Sounding rockets vertically probed the region between the limits of balloon flights and the lowest orbital satellites. NASA conducted many of these launches in cooperation with 16 countries. In aeronautical research, the X-15 rocket airplane soared to the fringes of space more than 30 times. New instrumentation was installed in the XB-70 2,000-mile-an-hour airplane. These studies are helping to design this country's supersonic transport. Also tested were vertical takeoff and landing planes, which may someday revolutionize air travel. Saturn I, the first generation in a series of rockets which will ultimately place men on the moon, completed 3 successful launchings. Here, being static fired, are the engines which will actually lift the Saturn moon rocket off the launch pad. The Apollo spacecraft also underwent rigorous testing. Paving the way for the flights to the moon, astronauts Virgil Grissom and John Young proved Gemini ready for longer and more complicated missions with their 3 orbits of the Earth. Next, our first long-duration mission, the 4 days of Gemini 4 with James McDivitt and Edward White piloting. The highlight, of course, was White's 22-minute walk in space. Gordon Cooper and Charles Conrad demonstrated that an 8-day lunar mission is feasible. They spent 8 days in orbit in the Gemini 5 spacecraft. After an Agena rocket failure, Gemini 6 was reprogrammed into a combined mission with Gemini 7 for the final manned space flights of the year. Astronauts Frank Borman and James Lovell left first in Gemini 7. Theirs was a long-duration mission, 14 days in space, one meaningful to future manned flights. Plenty of time to complete a host of medical and scientific experiments. 11 days after their departure, Walter Schirra and Tom Stafford boarded the Gemini 6 spacecraft and headed for a rendezvous with Gemini 7, a rendezvous in which the 4 space pilots circled the world in formation. Gemini, Ranger, Mariner, TIROS, orbiting solar observatory. These and many more made 1965 a year of significant progress in this country's peaceful exploration of space.
This has been an Aeronautics and Space Report, presented by NASA, the National Aeronautics and Space Administration.
The Rocky Mountains, 1/3 the landmass of the United States, yet inhabited by only 4% of the nation's people. Thousands of small communities, inaccessible by ordinary means of communication, exist in relative isolation. Now, with the help of NASA's application technology satellites, a unique educational service is being offered to many of these remote locations.
Good morning, welcome to Time In. I'm Gene Getting.
I'm Karen Beard.
Today we'd like to talk with Blanding, Utah and Busby, Montana, if we can.
To test the effectiveness of the system, junior high school students in 56 rural schools scattered over 8 states, including this one in Blanding, Utah, receive educational television programs daily. The programs, dealing with decision-making and career education, are transmitted via satellite from the Federation of Rocky Mountain States Television Production Center in Denver. Using simple, inexpensive antennas, the schools receive color television, and at 3 of the sites in each state, the students can also talk to their TV teachers in Denver. It's called Interaction.
Today's Tuesday, and as you know, that means that today's program talked about decision-making again. It talked a little bit about investigating your alternatives, gathering information about them, checking out their reliability and their probability. So let's get right on. And can we hear from Blanding this morning with any questions or comments you might have?
Hey, Jim, did you have a question?
Blanding with us.
NCC, this is BA71. Why are the 3 decision-making processes so important?
The question from Blanding is why is the decision-making process so important? Helen, Al?
Many people make decisions throughout their lifetime that they don't look at all the possible options that they have. And in fact, many decisions are made without having all the information.
We asked some of the students at San Juan Junior High School in Blanding how they feel they are benefiting from the satellite-transmitted TV.
Well, like if I want to do a certain job, well, how's it going to do? You can't learn stuff like that on TV. You can learn it here on a satellite program.
Oh, I learned a lot of things. How much education I need to get a certain job and all that stuff.
Oh, about how to make decisions in your careers and what kind of interests and abilities you need in certain careers.
Oh, like get you out of going to another class.
Another major part of the satellite television transmissions is a course offered every 2 weeks for teachers not directly involved in the career education programming. As with the student interaction, so too the teachers can talk directly to the experts in Denver.
Utah, BA71, will you come in, please?
This is Blanding. We had a question concerning the financing or the funds that were the way that you went about raising the funds for this fair. Over.
How did you go about the process of raising funds for this fair?
The first year that we did it, we did seek initial funding, and we went to the Junior League and the Chamber of Commerce and the State Departments of Education for that funding.
Education via satellite, extending communications into remote locations through the nation's first widespread trial of educational space technology.
This has been an Aeronautics and Space Report presented by NASA, the National Aeronautics and Space Administration. NASA, the National Aeronautics and Space Administration, presents Aeronautics and Space Report.
The This is essentially a converted third stage of a Saturn V that will be put in an orbit and provide living space for astronauts, and particularly astronaut sciences who want to do something useful in an orbital station orbiting the Earth at an altitude of about 200 miles for all kinds of scientific activities and practical applications. For example, attached to the space station.
The voice is that of Dr. Wernher von Braun, NASA's Deputy Associate Administrator for Planning. He is describing this country's first space station, scheduled for launch in 1972.
Other activities will deal with the Earth itself. Instead of looking into outer space and looking at the sun, you can also look down onto the Earth and make observations in fields like meteorology or Earth resources. For example, lay the groundwork for a global crop survey system and these kind of things.
At the Marshall Space Flight Center in Huntsville, Alabama, where the orbital workshop is being developed, astronauts have been training underwater in a huge 1.5 million-gallon practice tank. Scientist astronaut Donald Holmquist, who hopes to man one of the early space stations, talks about the aquatic training.
If you're upside down in the water, you still know you're upside down, but it doesn't bother you too much, and you still float freely. If you turn loose of what you're hanging onto, you stay in place. You don't sink, you don't rise. You weight yourself to be exactly in equilibrium with the water. And you'll see from time to time in the Apollo applications us testing various models of the orbiting workshop underwater. In particular, we have a test coming up which will involve the techniques with which we'll change the film in the Apollo telescope that we're using to look at the sun. Throughout the mission, from time to time, we have to go out and reload the film canisters. And so we go out through the airlock. One man goes out to the end of the telescope, stands there and takes out the film and passes it back by some means, maybe a pulley, to the man standing in the doorway. And we will work out all the techniques for restraining ourselves, passing the film around. We'll be doing this underwater.
Underwater training, one of the methods used to develop techniques for working weightlessly in future space stations. Looking toward the day when this country may want to send craft on deep space missions to distant planets, NASA is continuing research on electric rocket engines. Recently hurled aloft from the Western Launch Facility in California, CERT-2, Space Electric Rocket Test. Electric engines produce minute amounts of thrust and do it more efficiently than either chemical or nuclear rocket engines. Small thrust over a long time can do what a very large thrust does for a very short time. During the CERT-2 mission, one of the electric engines is to be operated continuously in space for about 6 months. Another spacecraft launched from the Western Test Range was TIROS-M, an all-new operational meteorological satellite. TIROS-M is providing both day and nighttime cloud cover pictures of the entire Earth. It is also sending back solar flare warnings. Satellites like TIROS have tracked nearly all of the 400 tropical storms, hurricanes, and typhoons since 1960, when the first weather satellite was orbited.
This has been an Aeronautics and Space Report presented by NASA, the National Aeronautics and Space Administration.
For 10 days, Apollo 9 crewmen McDivitt, Scott, and Schweickart methodically photographed the meeting and joining of their two spacecraft, and trips outside. Fired the various engines, and generally rehearsed a lunar landing and return. The near-perfect mission of Spider and Gumdrop paved the way for the next manned flight, Apollo 10.
Simply stated, the purpose of the Apollo 10 flight is a final test of the men and machines required to do the lunar landing mission. The flight will be 8 days in duration. Liftoff will be from Cape Kennedy on the Saturn V moon rocket. The flight will take 3 days to get there. After arriving at the moon, the work in lunar orbit will be characterized by a rendezvous with the lunar module. The two astronauts will enter the lunar module and put it through a series of paces, including a descent to 8 miles above the surface of the moon, much as we have to do on the lunar landing mission. After rendezvous and docking back with the command ship, the pilots will separate the lunar module and perform tracking and mapping exercises for the rest of the 2.5 days in lunar orbit. After that time, trans-Earth injection back to the Earth, a coast of about 2.5 days back to the Earth, followed by splashdown in the Pacific Ocean southwest of Hawaii.
Astronaut Thomas Stafford will be command pilot on Apollo 10. Here he's shown following the flight of Gemini 9, one of 2 previous space missions in which he took part. Stafford, 38, comes from Weatherford, Oklahoma, and has been in the astronaut program since 1962. With him on Gemini 9 was 35-year-old Eugene Cernan. It was on that flight that Cernan spent more than 2 hours outside the spacecraft. He now teams up with Stafford again for Apollo 10 as lunar module pilot. The 2 of them will fly within 8 nautical miles of the moon's surface. The 3rd member of the crew, and serving as pilot of the command module, is 38-year-old John Young. This will be Young's 3rd space flight. He flew twice before during Gemini. The 3 of them first worked together as a team when they served as backup crew for Apollo 7. While the astronauts have been training, their spacecraft and rocket have been readied for flight. From Long Island, New York to California, Alabama to Pennsylvania, parts and pieces come together for final assembly at the Kennedy Space Center, Florida. The end product? Nearly 9 million pieces and components stacked 363 feet high. Apollo 10, final flight before this country's first lunar landing. Since 1959, 73 men have been accepted into the astronaut program. Here, 9 of those most recently selected take part in jungle training exercises at the Tropic Survival School in the Panama Canal Zone. Although all U.S. astronauts have landed in the ocean after returning from space, the spacecraft are so designed that in an emergency, they can safely come down over land. Since there is a remote possibility that this could occur, all astronauts are taught how to survive in both the jungle and the desert. During their 4-day course in the wilds of Panama, the astronauts were dropped into the water in a swamp penetration exercise. Studied some of the various jungle animals at a zoo set up especially for this purpose. Took an overnight trek through the jungle. Chopped down trees for shelter and fuel. Built fires and cooked wild game. And met with some of the local Indians. At a place called Pasco, 100 miles southwest of Spokane, Washington, the astronauts took part in another intensive training course, desert survival. One of the first things the men had to learn was how to build a shelter to protect themselves from the hot sun. A combination of parachutes and life raft seemed to do the job. Improvise is the key word to desert survival. Here they dig a water still. By digging a hole in the sand and covering it with plastic, what little moisture there is in the soil condenses on the underside of the plastic and drips into a container. Even a crash helmet makes an acceptable shovel. Another important technique they learned was how to attract the attention of rescue airplanes. By using signal mirrors and markers, they made themselves visible from overhead. Hopefully, survival training will never have to be used, but should the contingency take place, the astronauts will be well prepared. This is the Bataan, General Douglas MacArthur's staff plane as it arrived in New York City in 1951. During the past 4 years, the famous general's plane has played an important part in this country's space program. After being completely outfitted with sophisticated electronic gear, it served as a simulated spacecraft, helping prepare people of NASA's manned spaceflight tracking network for Apollo missions. Although it looked like any other airplane to a casual observer, to the operators of a tracking station, it looked and acted just like an Apollo spacecraft. 3 engineers aboard the Bataan played the part of the astronauts, giving network technicians on the ground an opportunity to practice mission procedures, just as though they were tracking an Apollo through space. The Bataan flew its last mission before Apollo 12. The famous plane is now being readied for retirement and will take its place alongside others at the US Army Aviation Museum. It's called Mariner Mars 69. Mariner, the spacecraft, Mars, the destination, 69, the mission year. Mariner looks like this. Total weight, including scientific instruments, 850 pounds. This year, 2 Mariner spacecraft are being launched toward Mars and are expected to fly over different areas of the Martian terrain in early August. The closest pictures we have of Mars are those shot by an earlier Mariner from a distance of 6,000 miles above the surface. Mariners 6 and 7 will fly within 2,000 miles. The pictures transmitted back to Earth and received by these big electronic ears will show Mars surface areas as small as 900 feet across. In addition to the television cameras carried on the Mariners, special sensors will penetrate the Martian atmosphere and send back data, information that may help tell us of the probability of life there. Giving a brief status report, the director of NASA's Jet Propulsion Laboratory in Pasadena, Dr. William Pickering.
And we expect to get very much better photographs of the planet than we did with our first mission to Mars in 1964-65. The television system is a greatly improved system, the spacecraft is larger and heavier, and the communication system to the planet is very much better than it was back in 1964, and so far everything is working very well.
Mariner Mars 69, 2 planetary explorers which will rendezvous with the mysterious red planet late this summer. Planes that rise vertically, the same as a helicopter, then fly forward like a conventional airplane. Called VTOL, They are a unique class of vertical takeoff and landing plane, craft that may one day play an important role in short-haul air transportation. This VTOL, the XV-5B, is one of several planes undergoing flight tests at NASA research centers in California and Virginia. To supply the lift needed to take off, hover, and land vertically, the XV-5B makes use of two 5-foot diameter fans submerged in the wings. When landing or taking off, the fan covers are opened. When closed, the exhaust is directed out the tailpipes and the plane can fly forward at high speed like a conventional jet aircraft. Designated the XC-142, this VTOL was developed from NASA wind tunnel tests which began in 1956. The XC-142 rises vertically by tilting up its wings and engines. Once in the air, the wing is tilted down for forward flight. Studies on this particular plane are centered around VTOL landings in terminal areas when there is poor visibility. From an engine producing 15,000 pounds of thrust, the Hawker P-1127 VTOL literally rises and descends on a pillar of jet exhaust. This same engine can then push the plane forward at subsonic speeds. The P-1127 is being used to study approach and landing tasks and to train NASA test pilots for other VTOL programs. Vertical takeoff and landing aircraft. Research now to determine their future potential as short-haul intercity transports.